Okay, next we want to look at another example, all right? So the example is y equals to 1, all right, if the loan is approved. So success means loan approved. Uh, 0 means loan not approved. Okay, so this is based on the data, right? Loan logit probit, all right, which is also given to you. So you can take a look at it and try it and see whether you will get the same results as what we have here. Okay, there are many variables, all right. For instance, whether the person is, the applicant is old means above the median age, right, equals to 1. Also, may be dependent on income. Maybe the person has applied for bankruptcy before, whether the person is black, all right, what is the term of the loan, all right. So if the person wants a longer term for the loan, would it affect the probability of the loan being approved, for instance, okay? And the same thing for the rest of it, the amount of loan, all right? So if the loan amount is higher, would it actually increase the probability of the loan being approved, or would it be the other way around? Okay, so there are many variables here. Now, in the example that we will be discussing in the next slide, we will not be using all of this, right? We'll just use several of these. So we have whether the individual is old or not, all right? This is a dummy variable, is equal to 1 if it's above median age, 0 otherwise, and the annual income, whether the person has applied for bankruptcy before or not, the amount of loan, all right, other obligations, all right, other financial obligations that the person has, gender, okay, male equals to 1 if the person is male, 0 otherwise, and this is also marital status, married, dummy variable equals to 1 if the person is married, 0 otherwise. Okay, so this is for the LPM, this is for your logit, and this is for your probit. Okay, so we will find if you use LPM, okay, you find that the age matters, annual income matters, the person applying for applied for bankruptcy before matters, whether you get loan approval or not. The amount of loan also matters. If you have other financial obligations, it also matters. Your gender does not affect the probability of you getting a loan or not. The marital status do matter. Okay, so this is for your LPM. Similarly, if you find that if you apply logit model as well as probit model, you will find that the significance of these variables are similar. Okay, so basically the way that we interpret this, all right, at least significant at 5%, and you will also find that they are all the overall significance, all right, no problem over here. Okay, so you find no problem. So how do we want to interpret this, right? Because this is a negative number, it says that if the person is older, the probability of getting the loan approved will be lower. Okay, over here, right, which is quite surprising. Okay, if the annual income is higher, all right, the probability of getting the loan approved is lower because you have a minus sign. Okay, if you have applied for bankruptcy before, right, you will have the probability of getting the loan approved will be lower. Okay, if you request or applied for a higher loan amount, then the probability of getting the loan approved will be higher. Okay, if you have higher financial obligations, other financial obligations, the probability of you getting your loan approved will be reduced. Okay, you are less likely to get your loan approved. There is no difference in gender, So whether you're a male or female would not affect the probability of you getting your loan approved. But if you are married, all right, the probability of getting your loan approved will be higher compared to if you are not married. Okay, so it's the same, all right, the results as we said before are similar for logit as well as probit. So the marginal effects, okay, and the differences across groups, as what we said before, you can do the same thing. These are just the coefficients, estimated coefficients in the table that we had before for LPM, but for your logit, all right, and for your probit, okay, you have to do the computations at the mean, all right, so you can try that and see whether you will get the same results as what I have obtained. Okay, so basically at the mean you will have this. Okay, so compared to not married, okay, the probability of approval for married, this is again computed at the mean, all right, not necessary is always 0.91, all right, but this is computed at the mean is 0.91. For not married is 0.87. So it is higher if you are married. Okay. Similarly, for the probit case. Okay. Now we just give you the summary of what we have done. If you have, um, your probability models for LPM, right? The marginal effects for quantitative variable, this is a constant, but for logit, all right, this is how you compute your marginal effect. You have your estimated coefficient times by the probability of your y equals to 1 times probability of y equals to 0. So if you want to compute the marginal effect at the mean, you compute this z value that you have all at your x at the mean values. Okay, for your probit, you need to also do the same, all right, but now you are using your cumulative standard normal distribution. For your dummy variable case, okay, as what we said before, all right, what you want to do is compute this probability when d equals to 1 and probability of y equals to 1 when d equals to 0, all right. So this you compute it at the mean values of all your other explanatory variables except for your dummy variable over here. Okay, so for your logit, all right, as well as for your probit. Okay, so this is basically the summary of what we have before.